Hello students, today we are going to start chapter number 6, lines and angles. So first let us recapitulate some common terms like a point, line, line segment and ray. So you all know about all these basic points. So let us come to angles. So many angles like in this picture or in the wings of this aeroplane or in the hands of this Caesar. So this is an angle. Now how or what an angle is? So when two non-collinear rays join with a common endpoint, an angle is formed. For this, let us take an example of a ray BC and a ray BE. Now when these two non-collinear rays intersect or join at a point, this point is known as the common endpoint, and BA and BC, these are known as arms of this given angle. Now let us know how to name an angle. So naming an angle, to name an angle, we can name this angle as angle ABC or angle CBA, or we can even name it with a single letter as angle B. Now let us take two lines, line E and line B. Now when these two lines intersect, some angles are formed, and these angles are of different types. So let us know what are the different types of angles. That is an acute angle, right angle or obtuse angle. Now, you know, when a straight line is formed, it also makes an angle of 180 degrees. This is known as straight line angle or straight angle. Now, what happens if the measure of angle is greater than 180 degrees? So, this is known as a reflex angle, whose measure is greater than 180 degrees but less than 360 degrees. Angles. Now, these angles are divided into two angles. And these two angles, which are divided by this given ray, are known as adjacent angles. When the sum of these two adjacent angles is equals to 90 degrees, they are called complementary angles, and when they sum up to 180 degrees, they are known as supplementary angles, or they also form linear pair or linear pair of angles. Now look at these figures. They are forming some lines which are intersecting at a point and forming some angles. And these angles are known as vertically opposite angles. And vertically opposite angles are always equal. Now let us prove that here vertically opposite angles are equal. So let us take a line L and a line N and are intersecting lines and forming angle A equals to angle B equals to angle D. So for that we know that angle A plus B is equals to 180 degrees and angle B plus C is equals to 180 degrees. Both are forming linear pair. So, when the right hand side of both the equations are equal, so taking the left hand side. So, from first and second, we get angle A plus angle B is equals to angle B plus angle C. Now, angle cancel out angle B from both sides, we get angle A equals to angle C. And similarly, we can prove that angle B is equals to angle D, both vertically opposite angles as equal. Now let us take a case of two lines. In case 1, these two lines are intersecting lines which intersect or meet at a point. And in case 2, what happens when these lines don't intersect or don't touch each other even when extended? These are known as parallel lines. Let us take an example of a railway track. Now what happens when two lines are intersected by a third one, which is known as transverse? 8 angles are formed. Angle A, B, G, H are known as exterior angles as they rise exterior to the given line L and M. And angle D, C, F, E are known as interior angles as they lie inside or between these two lines L and M. These are known as interior angles. And angles D, H, C, G, A, E and B, F are known as corresponding angles. These are the angles which lies on the same side of the transverse line. Now angle DF and CE are known as alternate interior angles, and angle DE and CF are known as interior angles on the same side of the transverse, or known as co-interior angles. Okay students, I hope that you must have understood the basic concept. So let us start the chapter, that is the solution of exercise 6.1 now. So question number 1 of exercise 6.1 is, in figure, lines AB and CD as shown in the given figure intersect at O. Now this is given that line AB and CD intersect at point O. This is the point of intersection. Now if angle AOC, so this is angle AOC plus angle BOE, they sum up to 70 degrees, and angle BOD, you have to find, this is given that angle BOD is equals to 40 degrees, this is given. Now find angle BOE, so we have to find this angle and reflex of angle COE. So this is angle COE. Now reflex of angle COE is this, that is 360 minus angle COE. Now AOB is a straight line, so sum of these three angles, that is AOC plus COE plus BOE or EOB is equals to 180 degrees, that is angles on a straight line. Now this is given that angle AOC plus angle BOE is equals to 70 degrees. So replace this and we get the value of angle COE. So angle COE is equals to 180 degrees minus 70 degrees, that is 110 degrees. We want to find reflex of angle COE, which is equals to 360 degrees minus 110 degrees, that is 250 degrees. Now this is given that angle AOC plus BOE is equals to 70 degrees. This is given to us. And angle AOC, that is this angle, is equals to angle BOD, vertically opposite angles. So angle BOD is equals to 40 degrees, and hence what we get, in place of AOC we can write BOD, and BOD is equals to 40 degrees, and therefore angle BOE is equals to 70 minus 40, that is 30 degrees. Now question number 2, in figure, lines XY and MN intersect at O. This is given that XY and MN intersect at point O if angle POY is equals to 90 degrees and the ratio of angle A and B is equals to 2:3. Then find the value of angle C. This we want to find. By using the given figure, XY is a straight line, therefore B plus A plus angle POY is equals to 180 degrees, where angle POY is given to us as 90 degrees. So we get A plus B or B plus A is equals to 180 minus 90, that is 90 degrees. Now replace these angles by the given ratio. It is given that A ratio B is 2:3. So let us assume the value of A as 2x and B as 3 times x. So using the ratios, 2x plus 3x is equals to 90 degrees, that is 5x is equal to 90 degrees, and hence the value of x is 90 divided by 5, that is 18 degrees. So we can find the value of angle A and B. So A is 2 into 18, that is 36 degrees, and B is 3 into 18, that is 54 degrees. Now we have to find angle C. So we can find angle C by using linear pair or by taking the vertically opposite angles also. So you can find C by using any of these two methods. Now here C is equals to A plus angle POY, and angle A is of 36 degrees and POY is equals to 90 degrees, and therefore the value of angle C is equals to 36 plus 90, that is 126 degrees. Now question number 3, in the figure, that is angle POPQR. This is angle PQR, angle PRQ. These two are equal angles. This is given to us. And we want to prove that angle PQS is equals to angle PRT. Now for that, ST is a straight line. So what we get? That is angle PQR, this, plus angle PQS, this. This is equals to 180 degrees. They are forming linear pair. And similarly, angle PRT and angle PRQ, they sum up to 180 degrees, forming linear pair. Now in these two equations, right hand sides are equal, so we can equate the left hand sides. So what we get? That is angle PQR plus PQS is equals to PRT plus PRQ. Now cancelling the equal angles, these two are equal angles given to us, that is PQR is equals to angle PRQ. So we get the required result, that is angle PQS is equals to PRT. Now question number 4. In this question, given that in the given figure x plus y, this x plus y is equals to w plus z. Now we have to prove that AOB, this is a straight line, that this is a line, this we want to prove. Now in this given figure, sum of all the angles at a point is equals to 360 degrees. So x plus y plus z, x plus y plus z plus w, they sum up to 360 degrees. Now it is given that x plus y is equals to w plus z. So in place of w plus z, we can write x plus y, or in place of x plus y, we can write w plus z. So we get x plus y is equal to 360 degrees, or twice of x plus y is equal to 360 degrees, and therefore we get x plus y is equal to 180 degrees. And what type of angles are these? They are forming a linear pair, hence it is a straight line. AOB is a straight line. Number 5. In this question, it is given that POQ is a line and ray OR, this is the ray OR, which is perpendicular to this line PQ, and OS is another ray lying between OP and OR. This is given that. Now we have to prove that angle ROS is equals to half of the difference of angle QOS and POS. This we want to prove. And for that, now POQ is a straight line. So angle POS plus ROS and angle ROQ, they sum up to 180 degrees. That is the sum of angles on a straight line. It is given that angle ROQ is equals to 90 degrees, as OR is perpendicular to PQ, which is given to us. So in place of ROQ, we can write 90 degrees, or we get angle POS plus angle ROS is equals to 90 degree, or we can write angle ROS as equals to 90 minus POS and name it as equation number 1. This is our equation number 1, that is ROS. This angle is equal to 90 minus POS. Now we can write angle QOS as this angle as ROS plus 90 degrees. So we can write angle QOS as angle ROS plus angle 90 degrees. So therefore what we get, angle ROS can be written as angle QOS minus 90 degrees, and name this as equation number 2. Now adding these two equations, on adding what we get, ROS plus ROS become twice of ROS, 90 get cancels with 90. So it is equal to QOS minus POS. So transpose 2 to that side and we get angle ROS is equal to half of the difference of angle QOS minus POS, which is the required result. Number 6. It is given that angle XYZ is equals to 64 degrees and XY is produced to point P. So draw a figure. So let us take the figure. So this is angle XYZ, which is equals to 64 degrees. And this is the extended ray, that is YP. If ray YQ, this is the ray YQ, it bisects angle ZYP. So this angle is equal to this angle. This is given because YQ bisects this angle. So find angle XYQ and the reflex of angle QYP. So to prove this, let us find the solution of this one. XYP is a straight line. So what we get? That is XYZ, this angle, plus angle ZYQ, plus angle QYP. They sum up to 180 degrees. That is angles on a straight line. And we know that these two are equal angles. So we can write 64 degrees plus angle ZYQ plus QYP is equal to 180 degrees, or twice of angle QYP plus 64 is equal to 180 degrees. Transposing 64 to the other side, we get twice of angle QYP is equals to 180 minus 64, that is 116. And hence what we get? That is angle QYP. This is angle QYP, which is equals to 116 divided by 2, that is 58 degrees. So angle QYP is equal to 58 degrees and the reflex of angle QYP is equal to 360 minus 58, that is 302 degrees. Now we also want to find angle XYQ, which is equals to XYZ plus ZYQ, which is equals to 64 degrees plus QYP as shown in this figure. This is 64 degrees plus this angle, that is 58 plus 64, which is equals to 122 degrees. And thus we get angle XYQ is equal to 122 degrees and the reflex of angle QYP, reflex of this angle is equals to 302 degrees. Thank you. Thanks for watching. I hope you must have understood this exercise also.